This is gonna be the last video for this topic. Here, um, a 65-watt light bulb operates on a potential difference of 95 volts. Find the current in the bulb and the resistance of the bulb. If this bulb is replaced with one whose resistance is half the value found in part B, is its power rating greater than or less than 65 by what factor? Then here I'm summarizing. I have my power 65 watts, the voltage is 95. I, it is power divided by V, which is 65 divided by 95, and that is gonna give you 0.68. Then I can calculate R using Ohm's law, voltage divided by current, and that is gonna give me 0.14 kilo ohms. And from that also equation, the second one, I can calculate also the same value. Then I can use the Ohm's law here, I did use. And here I use the power equation. Both are gonna work. Now, part B, if the bulb is replaced with one whose resistance is half, then I can first create the first equation for that bulb. P1, it is V squared over R1, and P2, this is for the new resistor. And I know that R2, it is half of R1. Therefore, I'm gonna substitute these, and then I divide P2 over P1, and from that I can get that the power is gonna be double. Then double power of the new, which is gonna be 2 times 65 watts, and that is gonna be 130 watts. Now, we are going to introduce here an idea that is going to be related to first, like we were talking about, direct current, which is always is going to be like the voltage is going to be, let's say I'm going to have a dry cell, like the regular batteries that we are using. Then this is like it's going to give me 1.5 constant for the whole life of the battery. And therefore the current that I'm gonna get from that is gonna be always constant till it dies. Okay, we call this direct voltage or direct current, where I will have the value is gonna stay the same. On the other hand, I can have, or like what you can get from the wall, it is what is called alternating current, where the voltage here is gonna change or changes its magnitude and direction all the time. Therefore, you're gonna see that is here is gonna be a positive value, here is gonna be a negative value. Here it starts from 0, and then greater, it reaches a maximum, and then it's gonna go down. Actually, the dependence of the voltage here is going to be like a sinusoidal, which is V equals V0 sine 2 pi f times t. V0 here, it is this value here, which is the maximum. Sine, we know sine. 2 pi f, it is the frequency. Okay, that frequency, it is in hertz, and usually here in the United States we have 50 hertz. Also, we have the same dependence from I, it is I0 sine 2 pi ft, and this is for resistors, and therefore I0, it is the peak current, which is V0 over R. And we can find here that the average power for, because here, remember, we don't have one value, we have an average power, we call it 1/2 I0 V0. It is a recommended notation here to use a value from statics called VRMS. We call it the root mean square value, and for the voltage, it is the maximum voltage divided by square root, and you don't have to know why. And for the current IRMS, it's I0 divided by square root of 2. This is kind of an average value, or like we are calculating this using statics. This is the last question here, where if the cost of electricity in your area is 12 cents per kilowatt, what is the total cost, capital plus operation, of using a 60 watt incandescent bulb for 1000 hours? This is the lifetime of that bulb. If the bulb cost 25 cents and if it was replaced with a compact fluorescent light, we call these CFL, that provides the same light output but at at 1/4 of the wattage, which of course is going to be having the cost, but last 10 times longer. Like it's going to stay, its life is going to be longer. I can calculate E as power times T, and that is going to give me 60,000 watt hour. Kilowatt hour, it is, I can convert that to be 60 kilowatt hour. The cost is going to be 60 kilowatt hour times the price for the 1 kilowatt hour. This is 7.20, and the total cost is going to be 7.45 because I'm adding its price, which is 0.5, I believe, written here. Okay, no, 25 cents. Okay, for the compact fluorescent, I can actually, recalculate, and I'm gonna have 15 watt instead of 60 watt. Then the wattage is gonna be different, or the power is gonna be different, and therefore the cost is gonna be like, if you compare this one to this one, it is times 4, and therefore the cost is gonna be divided by 4. Thank you and have a great day.